Okay, let's be real. Your STA1501 exam is breathing down your neck. Time is not on your side, and you need the absolute must-knows to get through it. I've got you. We're about to do a high-speed run-through of the core concepts that will give you the biggest bang for your buck. No fluff, just the essentials.
All right, first things first. Take a deep breath. Seriously, panicking is not a strategy. A clear, focused plan is. And that's exactly what we're going to do. We're going to hit the highlights, the topics that are pretty much guaranteed to pop up on that exam. Let's get you ready. So here's our game plan, our survival guide. First, we'll tackle how to describe data. Then we'll jump into the rules of chance, probability. After that, we are going to master the famous bell curve. Then we'll cover how we go from a small sample to the whole population. And to wrap it all up, I've got one final tip to tie everything together. Let's do this!
Everything, and I mean everything in statistics starts right here. Before you can predict anything or test any wild theories, you've got to be able to just simply describe the numbers you're looking at. This is the bedrock. Okay, this slide right here, this is the most critical distinction in the whole course. You have to know the difference. Are you talking about everyone, like all students at UNISA? That's your population. Or are you talking about a smaller group you actually talk to? Maybe 100 students. That's your sample. And here's the trick to remember the terms. Population numbers are called parameters. Sample numbers are called statistics. P with P, S with S. Got it?
Now, don't let these symbols freak you out. I know, it looks like a different language, but think of it as a simple code. If you see a Greek letter, like mu or sigma, you know you're dealing with the big picture, the entire population. If you see a regular Roman letter we use every day, like X bar or S, you're just talking about your small sample. That's all it is. Greek is for the whole group, Roman is for the small piece.
So how do we describe what's typical in our data? We use these two guys. The mean is just the good old average. Add them up, divide by how many there are. The median is the number that's smack dab in the middle after you've lined all your data up from smallest to biggest. Quick exam tip. If you have a few really high or really low numbers, the median often gives you a truer sense of the center. This one is huge, absolutely crucial. The standard deviation just tells you how spread out everything is. Think of it like this. A small standard deviation means all your data points are huddled together, close to the average. A big standard deviation means they're scattered all over the place. It's the number one way to talk about the spread.
All right, part one is done. We know how to describe our data. Now let's start using it to figure out the odds of things happening. Welcome to the world of probability.
This is a contingency table, and it's your best friend for probability questions. It just organizes all the data so neatly. So here, we've got a survey of 1,000 people, and we know their province and their favorite music. Everything we need is right in this little box. Let's start with the easiest one, marginal probability. This is just the probability of a single event. Like, what are the odds that a randomly picked person likes jazz? You just go to the total column for jazz, that's 250, and you divide it by the grand total of everyone, which is 1,000. That's it.
Next up is joint probability. The key word to look for here is and. What's the probability that a person is from Gauteng and they like jazz? You just look for where the Gauteng row and the jazz column cross paths, and boom, it's 85. So the probability is 85 out of that same grand total of 1,000.
Now pay attention, because this is the one that trips people up. Conditional probability. The magic word is given. So, given that we know a person is from Gauteng, what's the chance they like jazz? Here's the crucial part. Our world just shrank. We're not looking at all 1,000 people anymore. We are only interested in the 350 people from Gauteng. That's our new total. Out of those 350, how many like jazz? 85. So the answer is 85 divided by 350. The bottom number changes. That's the key.
Okay, let's talk about the rock star of statistics, the single most important, most common shape you will ever see, the normal distribution, which everyone just calls the bell curve. So many things in real life, from test scores to people's heights, follow this pattern.
And here it is. Notice how it's perfectly symmetrical? That peak right in the middle? That's the mean, the median, and the mode, all hanging out at the exact same spot. And the total area under that entire curve represents 100% of all the possibilities. It all adds up to 1.
So how do we actually work with this thing? We use something called a z-score. I want you to think of this formula as a universal translator. It takes any data point from any normal distribution and converts it into a standard language that we can easily compare. So, what does a z-score really tell you? It tells you exactly how many standard deviations away from the mean your data point is. A z-score of 2 simply means your point is 2 standard deviations above the average. Once you have that z-score, you can look it up in a standard z-table, which you'll have in your exam, and it will tell you the exact probability of that score happening. It's like a magic key. And now we get to the whole point. This is the ultimate goal of pretty much all of statistics, using the information we get from our small, manageable sample to make an intelligent, educated guess about the entire population. This is called statistical inference. We basically do this in two main ways. If your goal is to estimate something, like what's the average amount of time UNISA students study, you use a confidence interval. You create a range and say, I'm 95% confident the true average is somewhere in here. But if your goal is to test a claim, like a company says, our new phone battery lasts 24 hours, you use a hypothesis test to see if the evidence actually backs that up.
Hypothesis testing seems complicated, but it's really just a formal recipe for making a decision. Think of it like a courtroom trial. You start with a claim, the null hypothesis, like this person is innocent. Then you gather evidence from your sample. That's your test statistic. You decide beforehand how strong the evidence needs to be. That's your alpha. And finally, you make a decision. Is the evidence strong enough to reject the initial claim? It's just a structured way to let the data speak.
Wow, we have covered a lot of ground, and fast. So how do you pull this all together for the exam? Let's boil it down into one simple, powerful framework. If you remember nothing else, remember this. Pretty much every question in STA1501 is asking you to do one of these three things. 1, describe your data. That's your mean and standard deviation. 2, predict what could happen. That's all your probability stuff and the bell curve. And 3, infer. Use your small sample to make a big guess about the population. Describe, predict, infer. That's the entire course in 3 words. And remember, what you're learning here isn't just to pass an exam. This quote really hits it home. Being able to understand data is a fundamental skill for modern life, just like reading and writing. You're not just studying for a test, you're learning a new language.
You've got the core concepts, you have a framework to hang them on. You know so much more than you did just a few minutes ago. Review these key ideas, keep a cool head, and trust yourself. You can do this. Good luck.